Take a look at this surface. The average person would consider it clean, because to the naked eye, that's exactly how it appears. But is it clean? A closer look under extreme magnification reveals something that might otherwise be overlooked. Numerous particulates and contaminants scattered across this tiny region within our view. Imagine the amount of contamination present on the entire surface. Today, many of our workplaces require strict clean room environments within which we take the responsibility for producing semiconductor devices, disk drives, biotech products, pharmaceuticals, and the like. In these critical areas, the consequences of contamination are very real and often quite costly. Take the semiconductor industry, for example. When you consider that a single microchip can be composed of 15 to 20 different layers and contain millions of devices at geometries far less than 1/100th the thickness of a single human hair, it's not difficult to see why any contamination, however microscopic, can do serious damage. The wiper is the principal surface cleaning tool for controlling particulates and minimizing contamination in any critical work environment. Over the next few minutes, we'll show you how to achieve the best results using a wiper by taking a systematic approach to cleaning. In other words, we'll look briefly into the necessity for using wipers, how to wipe for greatest efficiency, and how to select the wipers best suited to your work and cleanroom environment. This program is being sponsored by Texwipe, manufacturer of leading technologies for contamination control. You could say that in the manner in which they're used to maintain cleanroom surfaces, wipers share something in common with that great pastime, car washing. In order to truly clean a surface, a cleaning device must be brought into direct contact with it. While the wind and rain remove some dirt from your car's exterior, they still leave behind a residue that is bound to the surface. Applying a soapy rag or sponge is the only way to clean it off. Of course, there's a significant difference between the exterior of an automobile and a cleanroom surface. The cleanroom surface looks clean, even before wiping. Yet you're still faced with the challenge of having to remove potentially harmful sub-micron-sized contaminants that are too small to see. Wipers contact particles with strong forces, removing particles that cannot be blown off the surface, such as those that were deposited on this glass slide. Dry wiping removed some, and wet wiping removed virtually all of these particles. This modest-looking piece of material represents the culmination of extensive research into contamination control. When brought into direct contact with the cleanroom surface, the fibers of this wiper act as micro squeegees, providing the force necessary to dislodge contaminants so that they can be drawn into and trapped in the body of the wiper. Now, is there really a correct way to use a wiper? Absolutely. And since your goal in doing so is to remove contaminants, the last thing you want to do is redeposit what you captured in the wiper back onto the clean surface. With that in mind, you must not forget the fact that the wiper is a finite reservoir. Exceed its capacity, wipe too fast, or wipe in more than one direction, and you defeat the ability of the wiper to successfully remove contaminants. Before we discuss using wipers to clean up spills, let's take a moment to look at wiper absorbency. Knitted polyester fabrics are more absorbent and cleaner than woven cotton fabrics or non-woven blends. Whenever you intend to use a wiper, be sure to follow the safety procedures relevant to your worksite regarding the handling and removal of contaminants. For basic surface cleaning, you'll need to wear cleanroom gloves. Make sure to wipe them off frequently so as not to transfer additional contaminants to the cleaning area. Fold the wiper into quarters. This enables it to contact the surface more efficiently while giving you several clean sides to work with. Most cleaning of cleanroom surfaces involves wetting a folded wiper with a small amount of solvent and wiping in overlapping strokes in one direction. Always wipe with a 10 to 25% overlap between strokes. Wiping in a roughly circular pattern spreads contaminants from the dirty areas to the cleaned areas. Wiping in overlapping straight strokes with a new surface for each stroke prevents the transfer of contaminants from the dirty to the cleaned areas. To avoid recontamination, you should keep track both of the surfaces you've already cleaned and the areas of your wiper which are unused. Always wipe the cleanest surfaces with the cleanest areas of your wiper. If you're re-wiping a surface, apply only the unused portions of your wiper to it. In certain cases, you may be required to use a dry wiper alone on surfaces where liquids or solvents are prohibited. If you're wiping up a spill, your first priority should be to know what you're dealing with. Once you've identified the liquid, check its corresponding material safety data sheet for precautionary information. Hazardous spills should always be dealt with using gloves and wipers that won't degrade when they come in contact with the particular chemistry of the spill. Be sure to wear any other protective gear that is necessary for safe removal of the spill. You'll first want to blot up most of the spill with dry wipers. To clean up the remainder of the spill, wipe slowly, about 1 foot per second, from the cleanest to the least clean region of the surface you're wiping. When you're finished with them, all wipers should be disposed of in accordance with the procedures established at your site. Once again, the key to effective cleaning is to avoid bringing contamination back onto an already clean surface. So remember these 3 wiping guidelines. Always wipe in one direction, wipe from the cleanest area to the dirtiest, and wipe slowly from the driest to the wettest area. If you would like a free copy of Texwipe's easy-to-follow wiping guide, call the number at the end of this program. We'll be happy to send this poster to you. For more information on clean room housekeeping procedures, consult the Institute of Environmental Sciences document RP-CCO 18.2. In terms of the configurations and types of wipers available today, you have more options at your fingertips than ever before. Additionally, improved methods of applying metrology, the science of measurement, now make it possible to get a more precise look at the degree to which wipers release particles and fibers. Insights gained from this data are opening the doorway to the development of even more advanced wiper products for the future. So, as our final order of business, let's briefly take a look, a much closer look, at just what goes into a wiper. Wipers are composed of either synthetic material, natural material, or a blend of the two. While the fibers of most synthetic material are distinguished by their continuous filaments, natural fibers possess shorter, entwined, staple filaments. The fabric from which the wiper is made can be constructed from either knit, woven, or non-woven material. To obtain the correct types of wipers for your needs, you should first consider what class of cleanroom you're working in. Texwipe publishes a selection guide to assist you in making appropriate choices. It lists the optimum wiper types for each cleanroom class. Because there's such a wide variety of wiper types from which to choose, you also need to match the characteristics inherent in different wipers to the kind of work you intend to use the wipers for. Ask yourself, how important to your work is the wiper's cleaning efficiency, its absorptive capacity and absorptive rate, its resistance to chemicals or abrasion? Is an aseptic surface or the ability to dissipate electrostatic charge of primary concern? For instance, if your work places you around semiconductor manufacturing or research equipment where minute amounts of particulates pose a threat to product quality and yield, a seal-edge polyester wiper would be your best choice. Polyester possesses good absorbency, the best balance of performance characteristics, and most importantly, leaves behind the lowest levels of particles and fibers. Also strong and absorbent are wipers made of nylon. Next in line, with somewhat higher levels of particles, are polyester cellulose blends. In a situation where absorbency is paramount, but low particle and fiber counts are not critical, A wiper made from polypropylene cellulose polypropylene composite represents the logical choice. And while they can leave behind larger amounts of particles and fibers, wipers made from cotton are sometimes best suited for work around higher surface temperatures, where synthetic fabrics may not hold up well under heat. The bottom line is this: to choose the correct wipers for the job, you must carefully assess their performance characteristics in comparison to the level of contamination your work environment can tolerate. Today's state-of-the-art metrology techniques provide the data that can help you make an informed decision. At Texwipe, we've been able to get a clear picture of the number of particles released by wipers and related products through scanning electron microscopy. Ionic contaminants are measured with capillary electrophoresis. Non-volatile residues are determined using solvent extraction, drying, and weighing. Absorption rate and capacity are measured too. Fabrics like sealed edge polyester, highly absorbent and unusually clean, are well suited to the most critical and demanding applications. Well, as you can see, there's more to wipers than you could ever have imagined. By taking the systematic approach to cleaning, carefully selecting materials appropriate to your cleanroom environment, and using them wisely, you can keep these tiny threats to your work from becoming big problems. Your colleagues at Texwipe, thank you for watching.